A very good day to Dr. Arif. My name is Jia Qi, one of the group members from Group G. Our group members are Aliyah, Safirah, Jia Qi, Elvis, Guang, Muhammad Adib, Zuhairie, and Rosemary Jiun. Then I will pass to the next presenter. Thank you.
So the first question is in how many ways can be photographed at a wedding? Arrange 8 people in a row, including the bride and groom. So if the bride next to the groom, so first we need to consider that the bride and groom as a single person, let's say 8. Then 8 along with the 6 others, it becomes 7. So they can be arranged in 7 ways and the couple can be arranged in 2 ways. Therefore, the number of ways can be arranged is 7 factorial times 2, which is we will get 10,080 ways. So for the next question is if the bride is not next to the groom. So the number of all possible ways to arrange 8 people is 8 factorial. And we need to remove the number of the bride and groom is next to each other. So we will get 8 factorial minus 10,080. Therefore we will get 30,240 ways. For the last question is if the bride is positioned somewhere to the left of the groom. So the 2 position for the bride and groom is C at 2 ways. So arrange the bride and groom with the 1 way, which is the bride is on the left of the groom. Next we can arrange the 6 people in 6 ways. So the number of ways can be arranged is 8 factorial over 8 minus 2 factorial times 2 factorial times 1 times 6 factorial. We will get 28 times 1 times 720, and the final answer is 20,160 ways.
Hi, my name is Aliyah and I'm going to explain the second question, which is suppose that a password for a computer system must have at least 8 but no more than 12 characters, where each character in the password is a lowercase English letter, an uppercase English letter, a digit, or one of the 6 special characters. So the A question is how many different passwords are available for this computer system? So in order to do that, we're going to find the total of the English uppercase and lowercase, which is both 26, the digits, which is 12 digits, and also the 6 special characters. We're going to sum it all up, which we will get 68. And then in order to find the password, we're going to minus 48, we're going to minus with digit password, which will equals to 68 to the power of 8. We will continue this until 12, and then at 12 we're going to get 68 to the power of 12. And then after that, we will find the number of ways the password can be, which is we're going to sum it all up from the 8 until the 12, which is 68 with the power of 8 plus 68 with the power of 9, and 68 with the power of 10, and 68 to the power of 11 plus 68 to the power of 12, which we will get 9.9207 multiplied by 10 with the power of 21. Now I'm going to explain this B question. So we're going to sum up all the letters without the special character, which will be 62, and then the possibility of the password with a special character, which will be 3.2792 multiplied by 10 with the power of 21. So for at least one occurrence of at least one of the special character, which will be 9.9207 multiplied by 10 with the power of 21 minus by 3.2782 multiplied by 10 with the power of 21, we're going to sum this up, and then we're going to get 6.645 multiplied by 10 with the power of 21. Lastly, I'm going to explain the part C of the question. So 1 nanosecond equals to 10 to the power of negative 9 seconds. So we will going to multiply this second with the answer that we get in part B, which is 9.927, multiplied by 10 with the power of 21. And then we will get 9.9207 multiplied by 10 with the power of 12. We are going to change the seconds to hours by dividing it with 60 multiplied by 60, and then we're going to change these hours to days by dividing it by 24 hours, and then we're going to change these days to years, and then by dividing it with 365 years. So the time for the hacker to check each possible password will be 584 years. Thank you.
Thank you, Arya. My name is Jia Qi. I will present for Chapter 5, Question 3. The English alphabet contains 21 consonants and 5 vowels. How many strings of 6 lowercase letters of the English alphabet contain exactly 1 vowels? The location of vowel can be chosen in 6 choose 1 ways, so number of strings can be equals to 6 choose 1 ways times 5 times 21 power of 5, which will equals to 122523030. The next question is exactly 2 vowel. The location of vowel can be chosen in 6 choose 2 ways, so number of string will equals to 6 choose 2 ways times 5 square times 21 power of 4, which will equals to 72930,375. The next question is at least 1 vowel, so number of strings with 26 English alphabet will equals to 26 power of 6, which is 308915776. Number of strings without any vowel will equals to 21 power of 6, which is at 5766121. So number of strings with at least 1 vowel will equals to number of strings with 26 English alphabet minus number of strings without any vowels, which is 308915776 minus 857662121. The answer will be 223149655. The last question is at least 2 vowels. Number of strings with at least 2 vowels will equals to number of strings with 26 English alphabet minus number of strings without any vowels minus number of strings with exactly 1 vowels, which is 308915776 minus 857662121 minus 122523030. The answer will be 100626625. Then I will pass to the next presenter. Thank you.
Hello, my name is Mohd Zuhairie bin Ahadin. I will continue this presentation for Chapter 6, Question 1. So the question is, suppose that 150 people enter a contest and that different winners are selected at random for first, second, and third prizes. What is the probability that Ahmad wins of these prizes if he is one of the contestants? Total number of ways in which any 3 random people can be chosen from 150 is 150 choose 3. Ahmad is one of the 3 persons in the set which is chosen for winning. Now, other 2 persons can be chosen in 149 choose 2. The probability will equal to 149 choose 2 over 150 choose 3. So the probability will equal to 1 over 50. So that's all from me. I will pass this presentation to the next presenter. Thank you.
Find the probability of each outcome when a biased die is rolled. If rolling a 2 or rolling a 4 is 3 times as likely as rolling the other 4 numbers, which is 1, 3, 5, and 6, and it is equally likely to roll a 2 or a 4. For this question, first we need to set x as the rolling time. We know that from the question it mentioned that the rolling of 2 or rolling of 4 is 3 times higher than rolling the other 4 numbers, which is 1, 3, 5, and 6. So we can set it as the probability of rolling a 2 or rolling a 4 is equals to 3x, and the probability of rolling a 1 or 3 or 5 or 6 is equal equals to x. Moving on, the addition for probability of rolling a 1, 2, 3, 4, 5, 6 is equals to 1. So when we substitute the value of x into the probabilities, we will get it will equals to 10x. Now in order to find the probabilities of 1, 3, 5, and 6, we know that it is equals to x. So in order to find the probabilities, we need to substitute it with the total probabilities, which is equal to 1. But 1 is also equals to 10x. Therefore, x over 10x is equals to 1 over 10. And for the same goes for probability of 2 or probability of 4, which is equals to 3x. We substitute it with 10x and we will get 3 over 10.
I'm Jiun and I'll present the question 3 for the chapter 6. A pair of dice is loaded. The probability that a 4 appears on the first die is 2 over 7, and the probability that a 3 appears on the second die is 2 over 7. Other outcomes for each die appears with probability 1 over 7, so what is the probability of 7 appearing as the sum of the numbers when 2 dice are rolled? So from here, we have to let A be the first die, B be the second die, and list out all the probability for the first die as well as the second die. To get a 7 appearing as the sum of the numbers when 2 dice are rolled, we have to list out all the combination of the dice to give the sum of 7, which is A1 plus B6, A2 plus B5, A3 plus B4, A4 plus B3, A5 plus B2, and 6 plus B1. So since this is an independent event, we have to find the sum of the product of each combination. So from here we can get a result of 9 over 49, and this will be the probability of getting 7 appearing as the sum of the numbers when 2 dice are rolled. Thank you.
Question and answer chapter 5, number 1. A box contains 8 red balls, 7 blue balls, and 5 green balls. The balls are successfully taken out at random without replacement. Calculate the probability that all the balls are the same color. First thing first we need to do is to find the total number of balls, which are 20 balls, and we use it to find the total cases, which is 1140 cases. Next, we need to find the favorable cases for the 3 colors, which are 8 red balls, 7 blue balls, and 5 green balls, and we will get the result of 101 cases. Then we use both the total cases and favorable cases to find the probability, which is 101 over 1140 cases. Thank you.
How many ways can be arranged for 4-digit numbers smaller than 5,000 for the number 1, 4, 5, 6, and 7? So for the first digit, it can be done in 2 ways, which is 1 or 4, since the number must smaller than 5,000. Then for the rest, it can be done in 4 ways. If the first digit is 1, then the rest of the 4 will be 4, 5, 6, and 7. And if the first digit is 4, then the rest will be 1, 5, 6, or 7. Therefore, the number of ways can be arranged is 48 ways.
Thank you for the previous presenter. My name is Jia Qi. I will present for chapter 6, question 1. A nuclear plant has an emergency alarm system. When an emergency situation exists, the alarm system with probability 0.95. When an emergency situation does not occur, the alarm system sounds with probability 0.02. A real emergency is rare with probability 0.004. Given the alarm system sound, find the probability that a real emergency situation exists. In this case, we can divide into two, which is emergency and non-emergency. The probability emergency will equals to 0.004. The probability non-emergency will equals to 1 minus 0.004, which is equals to 0.996. In emergency situation, the probability alarm system sound is equals to 0.95. In emergency situation, the probability that alarm system not sound will equals to 1 minus 0.95, which is equals to 0.05. In not emergency situation, the probability alarm system sound will equals to 0.02. In not emergency situation, the probability alarm system not sound will equals to 1 minus 0.02, which is equals to 0.98. So when we want to find probability that a real emergency situation exists, we equals to probability emergency when alarm system sound divided by probability alarm system sound, which is equals to 0.004 times 0.95 divided by 0.004 times 0.95 plus 0.996 times 0.02. The answer will be 95 over 593. That's all for me. Thank you. I will pass to the next presenter.
I'm Yen. I'll present for question 2 of the Q&A. In class consisting of 25 students, 10 are girls and 15 are boys. 4 of the girls and 8 of the boys wear glasses. Find the probability girls and students wear glasses. First, we let probability of G equal to probability of choosing a girl, probability S equal to the probability of choosing a student who wear glasses. To find student who wear glasses, we sum out 4 of the girls and 8 of the boys. So it's 12 students who wear glasses. To find the probability of girls and student who wear glasses, we use the formula of probability G union S equal to probability of G plus probability of S minus probability of G intersect S. Value for the probability G is 10 over 25 and value for the probability S is 12 over 25. For G intersect S is actually the girls who wearing glasses, which is 4 over 25. So we sub this value into the formula, sum up the 10 over 25 and 12 over 25 and minus 4 over 25 to get a result of 18 over 25. And this is the probability of girls and students who wear glasses. Thank you.